once again welcome back to the DSA with DAX. Today is day 22 of our series. Okay, today we're gonna solve question number 557. It's basically a reverse word in a string triple I. Okay, and yesterday we solved question number 344, reverse a string. Okay, and I hope you got clear about yesterday's questions. And now we are in a phase 2, so you have to consistent for each and every day and try to do by yourself by multiple approaches. Okay, and I am Dax Patel with you this series, the master of DSA. Okay, we starting from the beginner, now we are in a intermediate level. Okay, and then we move to the advanced level. Okay, so okay, now I'll explain this question, then we move to the example part of this question, and afterward we discuss about this question's approaches, and then we write one code and discuss time and space complexity. Then we move to the tomorrow's questions. Okay, so without wasting time, let's start. So basically, this question is depends upon a string. Given a string as, okay, you have given a string as, reverse the order of characters. Okay, you have to reverse order of characters in the each word. Okay, you just have to reverse order in each word, not entire string, in each word within a sentence. Okay, while still preventing white space and initial order. Okay, you have to maintain initial order, like your you have like myself and your name, so you have to prevent order, but each and every word in your sentence you have to just reverse word, maintain the sentence order and the spaces in the sentence. Okay, this is the basically question is trying to saying. Okay, little bit complex question is there. Okay, now we'll see example so you can clear about it. So we move to the example one. So here are a string is given. Let's take lead code contest. Okay, so string is given. Let's take lead code contest, and it's converted to the like this. Let's reverse, then white space. Okay, then take reverse, then white space. Okay, and then lead code reverse, and then white space, and then contest reverse. Okay, and here you can one more example you can see. Mr. Ding. Okay, RM space GIN ID. Okay, so I hope you got clear about this example and question. Now, once we discuss about approaches, so you can more clear about how we can achieve this. Okay, without affecting the order and white spaces. So now move to the approaches part. So like for this question, we gonna use first like approach based on loops and if else conditions, where we firstly check for the like white spaces or not. Okay, if si is not equal to space, and then we can store it on a one temporary variable word, and after that we proceed. And one loop like basically take a new string and store, because they don't give us a specific conditions are like s dot length is 1 to 5 to 10 to the power 4, and s contains printable ASCII characters. S does not contain any leading or trailing spaces. Okay, there is at least one word in a string. Okay, all the S are separated by single space. They don't give us any specific condition like you have that much only space complexity or time complexity. So we can take a new string to store each and every sentence, and take also word variable to store temporary values. Okay, and then we can move second approach. We learned inbuilt functions. Okay, so for this question we're gonna use many inbuilt function, like we can use split, after that we can map that, and then reverse. Okay, and join it to the new string. Okay, so we can use that also. So currently I have just two approaches in my mind. Okay, we'll write for each and every approach code and test whether it is correct or not. Okay, so I'll start with one next approach our with loop. So first let take result. Okay, result equal to, currently we are taking an empty let. Okay, temporary variable word. Okay, now we have both. Now we taking for loop, let I equal to 0, I is less than s dot length. Okay, because s is our given string, that's why we are taking s dot length. Now we have one for loop, okay, which is basically iterating our whole s string. So now we have to take one if condition. Okay, you can see like not yet what I am doing. S of I, current value of I, like string s, is not equal to, okay, white space. Okay, in cases where s of I is not equal to space, at that time we use word, okay, plus equal to s of I. Whenever these conditions are happening, s of I is not equal to space, we just store in word, okay. And if like this condition is not happening, this condition, okay, whole condition, so we move to the else, okay. Else for inside this, okay, let j is equal to word dot length, okay. It's basically current words length, okay, and word dot length minus one, last character of the word, okay. And until j is greater than or equal to 0, we are keeping this loop up, okay. And each and every time decreasing, it's like we starting from the end of this our word sentence, like word is basically like my name ducks, okay. So we starting from the x to move to a to d, okay. We starting from the ending to move to the first. I hope you got clear about this. So now we reversing word, okay. So whatever we have to do, we reverse it our word, so we can use result plus, okay, okay, wait, okay, result plus equal to whatever we do is word of j, okay. Now we successfully reverse, and each and every word we can just directly add it to the our result string, okay. So this part is completed. Now we push our each and everything. But one more thing you have to see, we have to keep our white spaces there. So result equal to plus equal to, okay, we adding space after so that's why we pushing white space to the our string, okay. After that we also have to clear our word, okay, because we adding characters to the word. So when our use is completed, we have to clean it up. So taking word as a empty, okay. So now you completed some basic work about this, but still one thing you miss, okay. So whenever we taking as a condition white spaces are there, so you can take that word like starting from the white spaces to the end of the white spaces, but for last word you don't have at the end white spaces, okay. So for the last word we manually have to set the condition like loop for last word. You can take the word value and like it's reverse. Okay, so for last word you using for loop, okay. So let j, okay, this is only for last word equal to word dot length, okay. J starting from the word dot length of minus 1, wait, okay, minus 1 to j is greater or equal to 0, j minus minus each time, okay. Then afterward we using the result, okay, result, and result plus equal to word of j, okay. So now I hope you got clear about this question. So at the end we return result. Okay, so you can clearly see that our solution is accepted. Okay, both are the three test cases. Now I'll submit for further lead code test cases check. So basically you can see that this is also accepted, and for this question all 29 test cases are passed. Okay, so I hope we got clear about this. Okay, these approaches. Next approach is totally depends upon inbuilt functions. Okay, and after that we can discuss about time and space complexity for this. Okay, so I'll write code for the our second approach. Okay, so for second approach is also depends upon directly in return. We doing each and everything in return. Okay, return as. Okay, so we take our return directly string. Okay, then dot split, we are splitting our given string. Okay, splitting from what? Each and every white spaces. Okay, we're splitting our string to the multiple words where each and every white spaces comes. Okay, after that we use dot map. Okay, map for what? Map for applying multiple like iteration and conditions on it. That's why using map. Okay, from map word. Okay, word is equal to word dot split. Okay, now we have to give this what is word. Okay, so that's why each and every white space is after it becomes word. Okay, so then we have to use dot reverse. Okay, for reversing our string, so we can reverse, and after that we use join. This join is only for our current word. Okay, so that's why we don't using space in here. After that we using dot join for entire our string. Okay, so I hope you got clear about whatever we are doing in this question. So let's run and check whether it is correct or not. So you can see this approach is also correct, where we first taken our string, then split it according to the white spaces. After that, assign white spaces to the word and word to use reverse. Okay, each and every words. Okay, reverse and join it each and every word without taking any white space. And at the end, we can join word with spy spaces. Okay, white spaces. Okay, so now we can discuss about time and space complexity of our first code. So in first code, we're taking entire new string, okay, as same as to our current given string. So it's basically space complexity becomes order of n. Okay, another word space is in worst case it becomes minor, so it will don't affect our order of n. So space complexity is order of n, and time complexity is also becomes order of n while we using two loops, but first loop it's moving to the first index to the last index. It's basically moving to the first index to the last index. Okay, but another we using loop is for only like word length. It's basically smaller loop, so that's why it will don't affect our like time complexity. So time complexity and space complexity both becomes order of n. Okay, so I hope you got clear about time and space complexity. Now I'll run this code. Okay, so submit, you can check out for the like lead code text cases. So this is also accepted. Our runtime is 10 ms, and the our like all 29 test cases are accepted. So this is today's question. I hope we got clear about each and everything. So now we move to the tomorrow's question, basic details. So I'll show the you question. Okay, it's basically like 389 question. Find the difference. Okay, simple question. Okay, this one. Okay, this question you are given a two string s and t. Okay, string t is the generated by random shuffling string s, and then add one more letter at a random position. Okay, return the letter that was added to T. So basically you have given an string S, okay, and string T is the shuffled version of S, and added only one more extra letter to the T, and you have to find that letter and just return that letter. Okay, so like you can see that A B C D, and here A B C D E. So E is the extra added letter. So here are empty. Here you can see Y. So I hope you got about this question. This is simple question, but you have to be conscious about whatever condition you are taking and whether it is correct or not. Okay. So I hope you can try this question, and by multiple approaches. This is simple question, so you can do this. And after completion this question, you can post it on LinkedIn and Twitter and mention me. Okay, and okay, so if you not solve this question, we can solve this question tomorrow. And if you not started yet DSA series, link in a button. You have to start from now, okay? And from day one, where I'll explain each and everything about this series, where you can start and understand whatever series, how this series gonna work, and whatever you have to do is mentioned in that first video. Okay, so you can start, and each and every code we are writing in today's question is uploaded to your GitHub. You can check out. Okay, for and also it code contains C and C++ language also, so you can also do DSA and C++. Okay, thanks for watching the video. Meet on tomorrow's video.